Hello, everyone. Thanks for tuning in to this short presentation on why you should run your cloud workloads and applications on Microsoft Azure Cobalt 100 VMs powered by Arm Neoverse platforms. My name is Bhumik Patel, and I'm a software ecosystem lead within the infrastructure line of business at Arm. Let me spend the next few minutes talking to you about the Cobalt 100 VMs, its benefits, and the value proposition for you to consider running your workloads. Arm and Microsoft have a long-standing partnership over the years, which spans across different technology areas, such as IoT, the client space with Windows on Arm laptops, and the server and cloud infrastructure space. For the cloud market, delivering the Arm compute subsystem into the Microsoft engineering teams allows Microsoft to rapidly co-innovate and vertically integrate their hardware and software innovations, bringing Cobalt 100 to market. Cobalt 100 was announced at Ignite last year and went GA earlier this year for customers to leverage this across different workloads. Now let's look at the Cobalt 100 VMs and how it delivers up to 50% better price performance for a wide range of scale-out and cloud-native Linux-based workloads. It's available in 14 regions globally today and more regions coming soon. And there are general purpose and memory optimized VMs available. So if you look at the general purpose VMs, you have either 4:1 memory to vCPU ratio or 2:1 memory to vCPU ratio available. With the 4:1 ratios, these are ideal for scale out workloads, running your Kubernetes clusters, small to medium open source databases, application and web servers. And with the smaller 2:1 memory to vCPU ratios, you can run small databases, gaming servers, microservices, and your workloads that don't generally need high RAM per vCPU. And for the memory optimized, you can get up to 8:1 memory to vCPU ratios, you running large memory cache applications, data analytics, and your machine learning use cases. Customers are already leveraging Cobalt 100 and seeing benefits of the power efficiency and the performance benefits provided by the Arm architecture. Databricks are leveraging Cobalt 100 for their SQL serverless offering on Azure platform. Elastic is leveraging Cobalt 100 for their search AI-based services and seeing up to 37% better price performance benefits compared to the previous instances. And you could see across different industry segments how customers are leveraging Cobalt 100. Templify are using it for their document processing platform. All of this is possible because of the robust software ecosystem for the Arm architecture. So at Arm, we are investing in the Arm software ecosystem over the years, both by providing engineering contributions across multiple open source projects, building strong partnerships across various ISVs and different customer segments, and enabling developer experiences so that you can natively build on the Arm architecture in a very frictionless manner. This is a strength for us, which allows you to bring your workloads and seamlessly integrate your workflows, your applications, and build natively on the Cobalt 100 today. So how do you get started? So we provide best practices for running your cloud-native Linux-based workloads on Cobalt 100 today, right? So if you look at the software stack, there is robust support across the operating systems. All the major OS support Arm architecture. All the major languages support Arm architecture. You can get significant performance benefits by using the latest versions of a lot of these languages, including the engineering work we've done together with Microsoft on enabling .NET 7 and .NET 8 for the Arm architecture. So you could build a solid base on which your applications can be built on. If you're cloud native, right? If you're doing container-based deployments, you can build multi-architecture images very easily with Docker BuildX. You can leverage Kubernetes-based clusters, whether it's AKS, in the Azure environment, and even do hybrid nodes with bringing in the Arm architecture into your existing x86 deployments. So you can get started very quickly that way. We have native support for CI/CD tools such as GitHub Actions, and you can build your own or leverage the GitHub Actions managed services that they offer for you to seamlessly build on Arm. Once you have your tool chain in place, you can then look at your workloads and the performance profiling of your workloads, whether you want to leverage some tooling on that we provide guidance around, and or just to benchmarking of your workloads to kind of understand what type of benefits you are achieving. And last but not least, for developers, we have programs out there such as Works on ARM that provides you free access, whether to physical systems or credits at your cloud provider. Now let's take a look at some of the workload performance gains. So once you build your software stack and you're deploying your workloads, this is what you can expect. Performance gains across wide variety of workloads in the cloud. If you look at Nginx, you get over 2x percent gain on your API request per second. Redis over 50%. Similarly, for PostgreSQL, 26%, and SpecJBB gives you 53% better performance with Cobalt 100 over the previous generation of N1 Neoverse N1 based systems. So this benefits, you could see how it can provide you scale out benefits for your workloads, and you can map additional workloads that you bring to this environment. This is true across different segments, and one of the compute intense segments that you could find today is running your simulation workloads within the EDA space, right? So ARM is an early adopter of Cobalt 100, and we leverage this in production, running front-end simulation tools such as Cadence Xcelium and Siemens Questa-Sim on Cobalt 100, and these are the performance benefits you see both for perf per vCPU and perf per dollar benefits of running these front-end simulation workloads. If you look at the key workloads across the HPC space, such as engineering, molecular dynamics, climate and weather, genomics, you see performance gains across the board. So this is a very compelling platform for running compute-intensive workloads, in addition to building your cloud-native microservices workloads, as we saw earlier. So for you to leverage a broad range of software ecosystem that is available for the ARM architecture, we provide further guidance through our ecosystem dashboard. Here you can see hundreds of projects that are supported on the ARM architecture listed here for you to quickly check whether they are functionally enabled, what versions you can run this on, and quickly get started. And last but not least, we provide these technical guidances through learn.arm.com, where you can find how-to guides on specific applications and migration best practices if you are migrating your code from x86 to ARM, and specific to some of the Azure services, whether it's AKS or deploying .NET-based applications. You could kind of see a range of learning paths that are available. So there are a lot of resources available for you to check, and you can reach out to us as well if you have any questions. Thanks for listening in, and hope you have a great event.